Welcome to the Maine Science Podcast. I'm Kate Dickerson. Today's episode is a conversation I had with RJ Perry, who is the Laboratory Technical Manager at the VEMI Lab at the University of Maine. I've known RJ for years, and it was great to hear more about his background, how he got interested in science, his path, and what he did at VEMI when he first started, and what he and VEMI are doing now. And if you are a student at UMaine and you want to work for VEMI, and why wouldn't you after this conversation, send your resume to RJ. We'll include his contact information in the show notes. My conversation with RJ was recorded in May 2024. I hope you enjoy our conversation as much as I did. RJ, welcome to the Maine Science Podcast. It is a delight to have you here. I have lost track of how many years we've known each other. But even with all of those years and roping you into the Science Festival long ago when it first started, I don't have a solid understanding of your background and how you ended up in the great world of really remarkable science. So I'm going to let you get us to that point, and then I'm going to ask you more about your work now.
All right. So way back in high school, I was ostensibly a Brewer High School student, but they have a rather limited technical field, at least they did back then. I understand it's quite a bit better now. So I went over to UTC for half of my day for 3 years of high school, doing the robotics program over there. And that's really where I got into tech kind of in general. Learned a lot about programming, learned a lot about hardware, and just about logic, which ends up being important in a wide swath of things, right? So my last year of doing that, some UMaine students approached the class and they wanted to start a first robotics team. So I was part of the inaugural team 1995 from United Technology Center Region 4, which was, I think, the first robotics team north of Portland, basically, in the state of Maine. So that was a lot of fun. Through subsequent years of that, we also started hosting VEX robotics competitions all across Maine, and that's really taken off. They're everywhere now. And that's kind of what I was working on while I attended EMCC for 2 years, got my associates there in electrical and automation technology. They have a lovely 2+2 program. So if I do 2 years there, I can transfer up to UMaine, spend 2 years to get my bachelor's. So I did that, got my bachelor's in electrical engineering technology. At some point in there, I started working at the VEMI Lab, which is where I'm still working to this day, although in a much enlarged capacity over the programmer that I started as back when I was an undergrad. So stuck around here all through that, ended up getting my master's degree in spatial information science and engineering, and stuck around and I'm still here to this day.
I'm going to ask you to explain what spatial information engineering is, because it's really cool, but it is not well known.
It is not. It has nothing to do with outer space. I am not NASA. I do not do rockets. It has to do with perception and mapping, a lot of mapping. So there's a really cool program called ArcGIS. Really, if you see any cool map of the United States, they probably use ArcGIS to make it. It lets you make really cool images and do interesting statistics based on physical space as opposed to just random numbers. So it has a lot to do with that, a lot to do with database design. And yeah, I guess kind of all of these things together make up the spatial information science and engineering program.
So programming to spatial informatics, that's a pretty big path. That's a pretty wide.
Yeah.
From one to the other. And it's not obvious that you would start with programming and end up in spatial and mapping. And I know you're doing other stuff at VEMI, and we will get to that. But I'm curious, when did you decide that programming alone wasn't going to be enough of what you wanted to do? You said you studied engineering technology. So did you at some point figure out really early on, I just want to do more than coding? Then I'm not dismissing coding, but it's a very specific path.
So it is and no, actually. I ended up doing the electrical engineering technology program here instead of the electrical engineering course. And the biggest difference between those two is the technology programs are very hands-on and less theory-based. So there's a lot more labs. You get to work with microcontrollers hands-on a bunch. You get to do soldering, all that cool stuff. In traditional electrical engineering, you get to do less of that. It's a lot of theory-based and, designing motherboards and really crazy stuff. So my focus was already in the hands-on field. And then when I got my bachelor's, I did not immediately decide I'm going to get my master's. So I went out, did the job hunt thing, went on 10 or 20 interviews, a lot of them in Boston and 1 or 2 in New York. And I ended up getting passed over for people that either had their master's or had 5 years of experience. I was like, all right, well, you know what? I think I might just get my master's. I like you working at the University of Maine. I like working at the VEMI Lab. It's very easy for them to keep me on if I'm a master's student. So I looked around at what interested me. And I think the database portion of the spatial engineering made me really excited. So designing like how data is stored in a computer is really interesting to me. And that's something we have to do in, I think, 3 or 4 classes in that program. So I did that. And then my faculty advisor, Nick Giudici, is also one of the primary researchers at the VEMI Lab. So there was a lot of crossover there, which was nice. And my master's project was specifically about taking topographic maps, which most sighted individuals have seen a topographic map, or the ones with the concentric circles that denote, how tall an object is, specifically hills very often, and converting that into tactile graphics, because there is nothing like that for blind users. So that's kind of what my master's project focused on. I thought that was a really interesting thing to do, and I didn't think it was going to be that hard, and I was wrong, as so often is the case. And the act of making them was not incredibly difficult. But because this is a brand new way of understanding something, it was very difficult for the BVI community to pick up on how to use these. So I really need to continue to do more research in that field if I get some time, because I think it's a really useful thing. And I've only really done my master's project on it.
So which community?
The blind and visually impaired community.
Okay. So this is probably a good time to segue into what VEMI Lab is and what you do there. And then I'm going to dive into more specific questions.
The VEMI Lab is so much, and that's what makes it hard. We're going to go with a history lesson first, and we'll get to what the VEMI Lab is now kind of at the end. So originally, the VEMI Lab started as Nicholas Giudici's research lab on campus. And it, over a very short amount of time, kind of expanded. So he brought in Richard Corey, who is currently our director, and the two of them really focused on not just like doing research, but also educating students along the way. So they've always been very much of the undergraduate programming model, get undergrads to program whatever you need to run your research, and then run it with grad students and undergrads running the experiments as well, and working on the publication and getting authorship very early on in your academic career. So Nick's research early on was focused on human perception and some accessibility. A lot of his research used virtual reality as the medium to do this research, because it was much easier to change what someone is perceiving when you have control of the entire world, right? So we had this old, really expensive VR headset. This is well before the Oculus came out. We had like a VR resurgence in technology. And we'd have people come in and put the headset on and do perception tasks, learning a navigation route, and then like pointing back to where they came from, all this fun stuff. And it went really well. We had very successful early few years, had very rapidly expanded up to, I think, from the 2 undergrads that were there when I started to 12 or 14 undergrads within, I think, like a 3 or 4 year period. And we literally outgrew the lab that he had. So that happened. We moved over. We got our own building. We have a building on campus, Carnegie Hall, that houses the VEMI Lab. We now have 3 floors full of people between staff, grad students, postdocs, and undergrads. I think we usually have between 35 and 50 people employed at a time, depending on when graduation was usually. And our research has expanded as well. So we brought in another researcher, Jess Riccardi, who deals with, I think right now we're dealing with children with traumatic brain injuries, but she deals with looking at how the brain works more than what Nick does. So we're doing that. We've started doing a lot of work with autonomous vehicles and looking at how those are being accepted by the driving community at large, what car companies are likely going to want to do to make people interested in their cars, make them trust their cars more, and really to make sure that when these things get rolled out, there is that trust between the passenger and the car that kind of intrinsically exists between a car and its driver, or a driver and their passenger right now. We do a lot. Our research interests have expanded quite a bit from what they used to be. And that's kind of all the things we've been doing. We still do a lot of fun things, but it's harder to talk about in one breath now than it used to be.
Yeah, that's certainly true. And it's hard for me to actually realize this I think it was more than 10 years ago. I know it was more than 10 years ago when I was first introduced to VEMI Lab. And I do realize how unfair it is to ask you, so what do you do? Because it has expanded so much. So one of the really interesting things I think about VEMI Lab is the deep cross-interdisciplinary nature of your work, right? You don't just have cognitive science, and you don't just have engineering, and you don't just have electrical engineering. You've got this whole mix of things. And I happen to know, because I have an inside track, that, for example, you've got some physicists now. A group of them spoke at this past year's festival talking about haptic stuff. And I know that that's helped enhance some of the work just because they bring a different perspective, right?
Yeah.
Like everything else, they bring a different perspective. So in your role, you're managing all of these different pieces. Do I have that right?
That's correct. Yes. I am the lab manager at the VEMI Lab, and I mostly manage the undergrads, which we, as you mentioned, kind of hire from everywhere. So the thing that we're really looking for when we're hiring is that drive to learn something new and those creative energies. We want people that they've heard what programming is maybe, but don't know much about it, or they've heard through the grapevine that you can do research on human subjects, but they want to know more about that. Like, how does that work? And those are really the people we look at hiring, mostly regardless of where they come from, right? We've had social work students, we've had physics students, engineering students, computer science students, music students, forestry students, like all across the board. Because for the most part, the skills that we need, we teach here. So really what we want is someone who's interested in learning and being taught how to do these things, and ideally brings a new perspective that may be useful. One of the things that we like once our undergrads are in and trained is we propose that they try to submit for a Cougar project. That is a University of Maine funding source from the Center of Undergraduate Research, where the student themselves gets to pose a research topic and be paid to investigate it. And then they end up submitting that at, I think, the student symposium here on campus. And it really lets them dive into their own research interest, which is a really, really good stepping point, especially if the student is going to go on to grad school and eventually maybe has their own research focus as a faculty member in the future.
So how difficult is it for you personally to keep track of all the moving parts and who is doing what project-wise, right? Like, that is a not trivial...
It is not. So management at all is difficult. Management at a fast food chain is very difficult. Lots of moving parts, lots of people keep track of fast-moving environment. Management here, less of a fast-moving environment, more moving parts. So my day-to-day job will have me sit in 2 to 5 meetings, most of which I'm probably running. And I need to not only obviously remember who's on what project, but also specifically within a project, what they're doing. If they're working, what language they're working in, what problems they had recently, like the day before or the week before, that I need to check in to see if they've overcome those things. In addition, if things aren't going well, I will often need to sit down and do some programming with them so we can overcome these hurdles. So I need to make time out of my day to do that. And it's particularly confusing when you go 3 of these back to back, and maybe one is being programmed in Unreal Engine, which is, a computer kind of VR gaming software. The next one is being done in Swift, which is the iPhone programming software. And then the next one is React, which is a web dev software to make websites, right? My brain is constantly switching from A to B to C, and then back to A, and then back to C, and a whole bunch of chaos ensues. But I honestly really enjoy it. The thing that I miss most about my job from the early days, in the beginning of this story, I like programming a lot. I get to do significantly less of it these days because I'm managing all the time. So some of the bright points in my day end up being when my students are unfortunately very frustrated and need help programming, because I get to sit down and do some programming.
I was just going to ask what you miss from what you were able to do before. And do you ever have an opportunity to pick a project and kind of work on that a little bit more intensely than just managing it?
So when the students have problems, I get to step in and sit down. Especially there are some calm days where I can actually dedicate 3 or 4 hours and we can really tackle a problem together, which is nice. Occasionally, the worst happens, which is, one of our undergrads can no longer work with us due to, course workload or something else. And I need to pick up a project. And if we don't have anyone else to do it, then it does come down to me to program it. Because at the end of the day, the VEMI Lab has contracts either through grants or through private contracts that these things need to get done. And it's at the end of the day, my responsibility to make sure that they all get done.
I hadn't thought about the deadlines aren't merely academic. You said you have to switch back from program to program, language, which makes sense. How much do you have to switch back and forth between things like augmented reality, virtual reality, just doing plain old two-dimensional phone stuff? Like, is there a lot of that still going on too?
There is. We're still doing a lot of vibrotactile work on phones, which is basically as you touch specific objects on your phone, making it vibrate. It's the way that we try to present image-based information to the blind and visually impaired users. We do a lot with that. We're still doing virtual reality work. Most of the virtual reality work we're doing these days is actually based around UMaine campus tours and showing off like our PhD work in a way that is interesting for people to view. I don't think we have any VR headset grants right now because most of those have been replaced with our autonomous vehicle grants. So in the lab, we have a giant autonomous vehicle simulator. It's basically the cab of a vehicle surrounded by projector screens. And the projector screens, we project off a virtual world, and the cab of the vehicle is on linear actuators. So you can feel it moving around and it feels like you're in an actual autonomous vehicle. So a bunch of our virtual research has kind of been replaced with specifically the AV sim research, which is really cool, but is again, very different from even VR headset work. So yeah, there's a lot of bouncing around.
Okay, so you guys have way too many projects for us to talk about all of them. So I'm going to let you pick one that you want to talk about in detail, and then I'm going to ask you questions about it. So which one right this second would you like to talk about?
We should probably talk about the AV research. I think that's been the most exciting stuff in the recent past.
So this is the autonomous vehicle research.
Yeah.
I know just because of Nick's background and how VEMI started up, a significant focus has long been how to convey visual information to people whose vision is not great or they do not have vision. So question number one is, how much is that part of what you're also doing with the AV research? And I guess question number two is much broader. What are the other things that you're looking at to gauge things like how will people trust this? You had mentioned that earlier.
So for part one, the AV work originally is something that Nick wanted to work on, right? So we've kind of moved forward from accessible design, which is designing specifically so it's accessible to people maybe that have disabilities or have different experiences, right? Moving towards universal design, which is just making it in general more useful for everyone across the board. So that's why we wanted to not just do a virtual reality headsets. We needed the actual vehicle here so that, again, it moves when it moves. When it turns, it tilts, right? So you get those proprioceptive commands to your body. You can feel that movement. We have the speakers in there, so you can hear the sound of other cars as they pass. You can feel through the subwoofer we have the kind of the vibration of the road as well. So all that stuff is kind of the bed to start working on better ways to convey information to the users inside. So we've been doing work with natural language. So how to more naturally describe kind of the scene around the cab, how to correctly give instructions to someone as they leave or as they're entering so that they understand either what the car is planning on doing, where it's going to go, how it's going to get there, or when it gets somewhere, what does it tell you? Like, where is it parked compared to where you want to be? Are there any external obstacles you need to know about? All that fun stuff. So we've been working on different methods to convey that information, either through, as I mentioned, natural language, which is the car talking to you, or through vibrotactile interfaces. So maybe your phone interfaces with the car and you can get feedback by touching your phone and feeling the obstacles or objects around you, or really any other methods that people can think of. That's kind of what we've been focusing on for that.
Has artificial intelligence made its way into your work with this?
It hasn't yet. I'm sure that it will, especially because that's something that AI does very well, is a natural language description of things, right? Maybe not natural language is the wrong word. It's very good at describing to whatever level of need, I guess it's good at describing, right? And I'm sure if it's trained specifically on natural language, it could get very good at that. So
would that make what you're doing more complicated to figure out, or is that just another route that you can explore how best to take advantage of it?
I think it's just another route. I think one of the biggest hurdles with integrating something like AI into like a vehicle subsystem is right now AI is operating at a loss. Fiscally, they don't make money. They lose money constantly. And if you're going to embed something into every vehicle in the world, or every vehicle that comes out circa 2030 on, right, it needs to not lose you money constantly as you're using it. So I definitely think that it's going to get better at that. And at some point will be embedded in vehicles just to deal with this communication that AI does so well.
Okay, so the down and dirty part of the conversation about the AV research, who's paying for it? Is this basic research for the sake of basic research? Is it car companies? Is it a mix?
It's a mix. We've had contracts through 2 different very large car companies over the past 2 years to do work on this field. I think we've had a bit of funding from the Department of Transportation. We won a prize 2 years ago for our work on a smartphone app to help users get from the building to the vehicle. And then when they're in the vehicle, help them understand where the vehicle is going. So we got DOT funding from that. And I don't know if we've had any NSF funding for this. I don't think we have yet. I think it's all been companies and the DOT.
So the companies and the DOT funding, am I right in assuming that that is to look at a very specific problem and solve it, as opposed to the broader systemic overview that I would think of as NSF funding? Are you looking at, I'm just throwing out an example. Let's say you have a car company that's like, we want to figure out how to make all 4 wheels run independently, which I know is not what you're doing, but that would be like a very specific problem. Is that the type of thing that you're able to do, is carve out a piece of what they're looking at and help fill out the puzzle pieces?
Yeah, it is. So the DOT prize was a very specific thing. They were looking at how to make travel more accessible, kind of in general, but specifically when it comes to autonomous vehicles. The contracts with the car companies were a bit more open-ended. Private contracts are always a little weird, right? Because they care about vastly different things. So those kind of evolved as we were working on them. So we had early meetings with them over the things that we wanted to try to do. And then we took one small bite of a thing, did some tests on it, gave them the results, and then through conversation with them, figured out the next thing they're interested in. That's just kind of how the relationship works. So it's a little bit different. And I know we have some grants out for NSF to work with more of specifically the interior control of an autonomous vehicle, how you can do that and make that an accessible and universal control scheme.
So it's really interesting. I don't think it's obvious to most people that a university research lab will have contracts with corporations. I think it's more common than is known. Are you able to build out those contracts in a way that you are still giving opportunities to undergraduates to research, but not have the project fail, that you'll still learn something? Like, are there safeguards in place where students get to learn? One of the great things about a college education or any post-high school education that's done really well is you're not just learning stuff, you're learning how to be creative thinkers. And you need to do that. But when you have a contract, I could see where that would be harder. Are you able to build that stuff in?
It's honestly easier to build that into one of those corporate contracts than it is into a grant. And that's because the corporations we were working with, they're very interested in what doesn't work. Like, they want to know if something doesn't work. They also would like to know why it doesn't work, ideally, right? But the fact that something has failed is relevant information to them. Very often when things fail in an academic setting, you can't publish on them. No one's interested in the 17th way that water doesn't fuse to granite. They're just not interested in another way that things don't work. And often they should be. Like, there's a huge debate here, right, about things that should be published in academia that often aren't. But because of the way that the corporate contracts work and the early conversations we had with them, like, they understand that a lot of this work is being done by undergrads. And they're fine with that. That's actually good for them because those undergrads might be people they want to hire once they graduate. So no, it's actually honestly a little bit easier to deal with that with corporations, I think, or at least the corporations we worked with, I should say.
That's a fair caveat. If you were able to pick any technology or project in the whole world that you would want to be working on for the next 5 years, what would it be?
I don't know. I mean, that's kind of the stuff I'm already dealing with. Like, I really like the stuff we're working on. I'm also not a research person. That's important to note. We have a whole team here, a whole other side of the building that is the research focus that I work with to decide what we're going to do. And I try to find the coolest tech or the most appropriate tech we can use to make that happen, to facilitate that. So I really just want to keep getting in whatever the new headset is. I want to get that in. whenever there's a new piece of tech, I want to get that in. So we've got something out here by Ultra Haptics. It's like an in-air display. And we did a little bit of research with that, and that was really fun. It was not super rewarding. It did not work for the thing we wanted to use it for, which is fine. As we just mentioned, that's fine, but it was cool. Every now and then something new happens in the smartphone world where they add something. The thing I would really like, iPads to have vibration motors in them. That's what I would like.
Oh, I didn't even think about that because I don't have one, but wow.
They don't. Android tablets do, which is great, but iPads don't. So we can't do a lot of our research that we want to do in the Apple environment on iPads. So we're limited on screen real estate. That's my one gripe about that at the moment.
That's super interesting. Do you know why they don't?
I'm guessing it's just cost savings. Like most people wouldn't need a vibration motor on an iPad. It's my guess. It's lighter and cheaper if they don't include it. So they don't include it.
I'm really glad you mentioned that there's a distinction between research and then helping fulfill the research or figuring out how to make the research happen, because that's also really important and a really great reminder that not only do these advances not happen in a bubble by one person, but rarely do they happen with only one focus and one team, that you need people who maybe aren't interested or their sweet spot isn't thinking up the one $1 million question, but it's not enough to just think up that question. You got to figure out how you're going to figure it out.
Yeah.
Rarely, to me anyway, is one person able to do all of that. So I'm really glad you reminded people who are listening that you just cannot get at these things with one person or one focus.
Yeah. And any fully funded project for us has multiple teams working on things. And even the unfunded stuff, we'll usually have like a small team when we're doing like exploratory research into like, could this be possible so we could write a grant about it? That's still going to have a team of at least 2 people on it. Almost nothing we do here is solo. I think with the possible exception of the Cougar projects that I mentioned earlier, where the undergrad is the researcher and the developer and all that stuff. And that doesn't need to be one person. If they want help or if they want to put another person on their Cougar, they're able to. So you should always try to have someone else working with you on whatever you're working with.
Yeah, if only because it's helpful to bounce ideas off someone besides you just talking out loud to yourself.
It really is. That's exactly it. So one thing we try to do here with my development teams, we can't right now for the summer because so many people graduated. But when we have the staff numbers to do it, we like to practice what's called paired programming here, which is 2 people at the same computer working on the same code. And there are limitations to that, right? There's only one keyboard, there's only one mouse. So you'd think that sounds really weird. Why would you do that? But the act of having someone else with you, either to look things up or to pose ideas, makes the whole programming process just go faster. And I think it makes it a better learning experience for both people that are involved.
It is not at all intuitive that one keyboard and one mouse with 2 people would go faster.
It is not. And if you try to watch that on TV and you watch like NCIS and you have 2 people coding on the same keyboard on the left and right side, that's not how it works. That's not what we do. The actual practice of paired programming, I think, is very useful, especially when you're learning a new language or a new environment.
Well, RJ, this has been a delight to talk to you. I honestly think we need to stop now because otherwise you and I are going to go on for hours and hours and hours. We barely touch the surface in some ways of what you do, but I have been a fan of VEMI for a long time, as you know, but also I've always enjoyed talking with you, and your enthusiasm for what you do is contagious. It almost makes me want to do programming. I mean, not really, because there's no way, but I really do appreciate it. And I never get bored listening about what you guys are doing now and next. So I appreciate it.
Yeah, absolutely. Thanks for having me. It's always fun to talk about things. Always fun to give little history lessons about the lab, and talking about our research is something that we kind of got to keep doing it. That's really important. That's why you do the research.
Thanks for listening to the Maine Science Podcast. Make sure you never miss an episode by subscribing on your podcast platform of choice. And please leave a rating and review. It will help more people find us and help spread the word about some of the remarkable people doing science in Maine. The Maine Science Podcast is recorded at Discovery Studios at the Maine Discovery Museum in Bangor, Maine. The Maine Science Podcast is executive produced and hosted by me, Kate Dickerson, and edited and produced by Scott Loiselle. The Discover Maine theme was composed and performed by Nick Parker.